Hello. So today we are going to learn some more area, but we're learning about the area of something called a regular polygon. We may have talked about what a regular polygon is earlier in the year, but if not, we'll define it again today. This does use a little bit of trig, so we'll go over that. But overall, it's a pretty easy section. All right, let's get started. Okay, so first let's define what a regular polygon is. So a regular polygon is a polygon where all of the sides and angles are congruent. So like an equilateral triangle, for example, would be considered a regular polygon because all the angles are the same, all the sides are the same. A square is a regular polygon. All the sides are the same, all the angles are the same. There actually is a list at the end. Here, I'll show you of the names of regular polygons, just in case you don't know them. I will attach this on Classroom too, but pentagon, hexagon, heptagon, and so on. Now, these are the names of just any particular shape with that many sides, but we're going to be focusing on ones that are regular. So all the sides and all the angles are the same. And these pictures here are examples of the regular versions of them. Okay, so that's what a regular polygon is. Couple more definitions. The center of a regular polygon is basically just a center right in the point. So if you were to put a circle around the figure, that's what a circumscribed circle is. It would be the center of that circle. Polygons, a regular polygon would have a radius too. So if you look at this picture, this would be the center. This would be considered a radius. So the radius is from the center to the edge, because if you were to put a circle around it, which I don't know if this is going to work. Let's see if it makes it a good one. Oh, decent. So that's what a circumscribed circle is. The corners are supposed to be on the circle, but I did my best. So the radius of the circle is also the radius of the polygon. Okay, what else do we have up here? I just told you what a circumscribed circle was. An inscribed polygon, we've already talked about that. So when I just put that circle around the figure, the polygon itself is called inscribed. Apothem. Okay, here's an important one. An apothem is a segment that is drawn from the center and is perpendicular to the side. So apothem is important because we need that for the area. So here would be an example of an apothem from the center to the side, and it's perpendicular. So that would be an apothem. This is not an apothem, that's a radius. Okay, a central angle of a regular polygon, it's kind of the same thing as like what a central angle is for a circle. Basically, if you look at this picture, whoops. So if you look at this picture here, these are the central angles. So a pentagon would have 5 central angles. Since it's a regular polygon, all of the central angles are congruent. As you can see up here, to find the measure of a central angle, you just do 360 divided by n, which n represents the number of sides. So n equals number of sides. Okay, and then right here is the actual formula of the area of a regular polygon, where A stands for the length of the apothem, and the capital P stands for the perimeter of the polygon. So you do 1/2 times the apothem times the perimeter. So most of the time you have to either find the apothem or you have to find the side so you can get the perimeter. And so that's where the trig will come in. Okay, so let's do our first example. It says find the area of the regular polygon with side length 8 inches. So this side length is 8 inches. This is a pentagon, which is 5 sides. So the perimeter, which we're going to need for the formula, remember, is 8 times 5, which is 40. So that takes care of that. We need the apothem now. So remember that this is the apothem. And so what we're going to do is we have to find, well, I'm going to label it A. We're going to find A. So if this bottom is 8, each of these pieces is 4. And then we're going to find the central angle, which is this whole thing, which if we cut in half, it'll give us the small one. So then we're gonna use like this triangle to find A. I just made a mess of that. So let me erase a little bit to make it a little neater now. I'm gonna zoom in on it too, so it's easier for me to write on. Okay, so here's the apothem. I'm gonna label it A. This is 4. We have to find this angle. To do that, we have to find the whole thing. So we're going to do 360 divided by 5. That's for the central angle. 360 divided by 5 is 72. So that means that this whole thing is 72. Half of 72 is 36. It's hard for me to write in here. Hold on one sec. Let me zoom in a little more. So this side's 36. And this side's 36. Okay, so now what we're going to do is we know that this is 4, this is A, so we're going to use trig to find the apothem. I don't know why this is messing up. Okay, so remember with SOHCAHTOA, we have this 36-degree angle. This is opposite, this is adjacent. So we're going to use tangent. So it's going to be tangent of 36 equals 4 over A. So to solve here, we have to bring the A up into the numerator. So we're going to multiply both sides by A. So then we're going to have A times tangent of 36 equals 4. And then to finish solving, we're going to divide by tangent of 36. Okay, so in your calculator, you would do 4 divided by tangent of 36, and we end up getting A is equal to 5.51. So that's the apothem, is 5.51. So now, finally, to get the area of the whole shape, we're going to take the apothem with the perimeter, and we're going to plug it in. So I guess I'll squeeze that in up here. So we have area equals 1/2 times the apothem, which is 5.51, times the perimeter, which is 40. So if you put all of that in your calculator, for this one, you end up getting 110.2. And that's square inches. Okay, I'm gonna have to switch to the Elmo. I don't know why my stylus isn't working right now, but that's supposed to be 110.2 square inches. So that's that one. I'm gonna end this now and switch over to my Elmo because this is not working. All right, so see you in a minute on video 2.